This is Canberk Akduygu. I came from Istanbul, and I am going to talk about mobile peer-to-peer communication testing with Appium. And let's start from who I am. As I said, I am Canberk, and I'm an ex-Java developer. I worked for a finance company for 2 years in Istanbul. Then I got fat because of working as a Java developer. We were working so many long hours, so I quit my job, and I started working as a SDLC consultant in IBM in Turkey. Then I realized that QA is a good thing because there were no QA in my finance company, no QA processes, and we always hated business analysis because they are always talking about this is not working, this is not working. Nobody is telling something good to us. So I realized that QA is a good thing also. They are not always telling the bad things, but they are giving also the good news. So I started working on the QA area also. Then I moved to another finance company where I worked as a test automation and performance engineer guy. Right now I am working in Testinium company as a chief test architect, and I am also a product owner, a tool called Lodium, where you can run your JMeter-based test on cloud. And I am also a constant blogger on softwaretestacademy.com. And what we do in Testinium, we are based in Istanbul, Turkey, and we are always doing some R&D stuff about automation, performance engineering, security thing. We are working on technical test area. And we have a device lab for mobile automation and a variety of browser combination for web testing. And we are more than 120 people with plus 90 engineers and consultants and more. It's a big company for. So what am I going to talk about? And first, I'm going to talk about the application under test. This presentation is about a real-life case study. And I'm going to tell the application under test. Then I'm going to talk about the challenges, solutions that we faced during the project. And I'm going to show you some code bases for the project and the Sidekick components that helped us build the Testinium grid. And hopefully we are going to have some QA session if it's okay. And the application under test is called BIP. I don't know if you ever heard it. Is there anyone? And Turkcell is a telecom company in Turkey. Is the biggest one. It is the biggest one. And they have a chat application called BIP. It's like you can think about it as a WhatsApp. But there are so many features like gaming, mobile payments, social platforms, VoIP video calls, etc. It's like a WhatsApp version of Turkey. There are 18 million downloads for this application, and then it supports iOS and Android. And it supports 9 countries. It's a big project, and it's a big application. They told us to automate this application, but they wanted us to automate the messaging part, the VoIP part. So the test case should run both devices. And it's a little bit challenging while Appium, because Appium always controls one device, and you have to add some more new features. And they told us to support Android and iOS with more than 20 or 30 devices, so we had to build a device lab. So you have to deal with this browser complexity, device complexity. So let's see what we did. And dealing with the mobile test environment is a little bit harsh when it comes to a mobile device lab. Think about you have 30 devices. 30 devices, 10 iOS and 20 Android. The versions changing, the device size changing, everything's changed. It's very harsh environment. Why is that? Also, like they told us to automate in iOS 9, 10, and 11. So what you have to do? You have to get Xcode, different versions of Xcode, 7, 8, 9. They have to be linked to each other. For Android, we have to support Android 5, 6, and 7 versions. Right now we are supporting the 8th version, but I didn't put in the slides. So for those, we have to get different Appium versions, like 1.53, 1.6, 1.36. And they have to be linked each other. So it creates a complexity for us to maintain manually this process. I say it's a mess, but this is something that we have to deal with. Don't take it on me. So we wanted to create our own solution on top of it. So we can get a neat environment. It's not like the other one, this thing. We want something like this. I hate this. Sure. Okay. So we wanted to build our extended grid solution. A basic mobile automation implementation is working like that. You have a Selenium grid in the middle. You have some Appium nodes and your devices. And all the Appium nodes are linked to another device. And you have to manage the capabilities on the source code level. Like if you have an iOS Android 7, you have to do some capability overriding for UI Automator 2. For the other ones, you have to do something else. And there are so many if-else structure in the source code base. So we wanted to get rid of it. So we extended our Selenium grid solution and named it Testinium. So what it does, you have the Appiums already linked, connected to it, and there are some JSON files that gives the properties to this environment. So Testinium grids overrides the capabilities according to the JSON files properties. Like you don't have to worry about the XUI test or instrumentation. You have a iOS 9 device, 8 device, and you have to know which instrumentation or which testing framework you have to use. Or for Android, you have to select one of those two, and you have no idea. But Testinium grid knows which one to add to your capabilities. So you don't have to deal with the capabilities. Testinium overrides the capabilities and do so much stuff. And the second challenge is that distributing the test in different devices. Like this scenario. You have to automate a scenario. What you do is you create your code, you build the project, and you want to run in parallelly. The same scenario runs on every device with the same steps. But when it comes to messaging, it's different. Like this. Our scenario is sending a picture to another people. So one device sends the photo. What happens? The other device receives the photo, downloads the photo, and maybe replies back to other device. And the other device checks the reply. So this is the end-to-end flow that our test cases. It's not running on one device, it runs on two devices with different steps. So this is the parallelism that we have to deal with. It's not a real parallelism, but it's some kind of parallelism. So we have to synchronize the device. For the synchronization, we started thinking, what should we do? Like here, I send a photo. What should the other device do? Wait for 30 seconds with a thread sleep? No, it's not appropriate. And we can use waiters, implicit or explicit waiters, but our test environment is not good. Sometimes the message reaches the other phone in 10 seconds, sometimes in the 20 seconds, 30 seconds, maybe sometimes it's 1 minute because of the instability of the test environment. So we also eliminated the implicit and explicit waits. So what can you do? How the other phone is going to wait for the other one? So we built another synchronization module on top of the Appium. So the devices can work in harmony. Like this is our extended grid. It is talking with the devices via Appium servers. And the device should talk to each other. Because this Android phone is going to send a message to the iOS one is going to send a message to another Android device. There's a synchronizer module. What the synchronizer module is when the Appium servers are running, there are two Appiums for this example, and there are two phones. The first Appium tells the phone to become the sender. So it gives a role. It's a role-based thing. And the other one to say that you are going to be the receiver. So the phones know that their role. He says that I am the sender, and I am the receiver. Then they get registered into a synchronization service with a RESTful APIs. And then the scenario starts to run. And this synchronization service tells one of the phones that to send a message. You can send a message because the other phone is ready to receive the message. So what this phone does, it sends a message. He says, how much is a Bitcoin? And the first one sends a message to the synchronization server that I sent my message. And then the second phone, what it does, it's always checking, it's a pooling mechanism to say if there is any unread message or anything that comes to me. He is always checking, the other phone is checking every second. And when it receives the, I have a message, he sends a reply like, don't ask, bankrupt on the way. So they go to synchronization server. If they have a message or something to read or something to send, so they start talking to each other. Then he says, I replied the message, then it goes on like that. The synchronization server always keep the synchronization between those devices. And we have our sidekicks. This customer doesn't want to deal with the taking screenshots or recording videos or phone utilities for, like Telmo mentioned, like you want to change the Wi-Fi to 3G, 3G to 4G, or you want to cancel the Wi-Fi during a messaging part, because this is something that you can encounter during a day. While you are working with your phone, when you go in a parking lot, maybe your device is going to lose the connection, and there will be some problems. So you have to get some phone utilities. So what our sidekicks are, is taking the screenshots. Taking screenshots in Android is very easy. If you are familiar with the Android Debug Bridge, ADB, and there are so many good functionalities like capturing screenshots. But in iOS, we did something different, and we used the LabEye mobile device plugin to capture screenshot from the Android iOS devices. And also we implemented those solutions into our grid, and we put a video recording module. So you can parameterize the test by saying, record the video, take screenshots, and all the thing is going to be handled by the Selenium grid. And Android has a native video recorder you can use by ADB, once again. But the limitation is that the videos are taken, are maximum 3 minutes. So if the test case runs more than 3 minutes, we add videos after test finishes, and we do some editing, and we create the videos. For iOS, there is no native video recorder, so we capture screenshots for a second for 6 or 8 times. Then we combine them with a Ruby script. So we produce the video also for iOS. And how does it work, this taking screenshots, videos, etc.? And on the top of it, there is a standard grid implementation. And this is ours, Testinium grid. We have extended grid agent, and we have extended node agents. And Selenium grid sends Appium to start video recording request. Like it sends a screen capture request, or app install, uninstall, or upgrade request. Those are all custom requests, custom implementations that we have done. So whenever the Selenium grid sends a message to Appium node, and this Appium node is talking with the device type, it starts to record video recording or the screen capture by using the before session and after session functionality of the Selenium grid. I don't know if you are familiar with the structure of the Selenium grid, but there are some methods like before session and after session, or before command or after command. So before session, we start the video recording, and we tell Appium to start collecting the screenshot. So it sends back to the server, and after the session, it stops taking screenshots. Or after every command or before every command, we can take screenshots. You can override those methods to do anything you want. And we have also a capability, a property file to manipulate the filtering for the commands. Like, I don't want to take screenshots when I wait something. I only want to take screenshots for click methods or send keys method or select methods. We can also filter those commands via this Selenium grid. And we are also dealing with the native components of the phones, like Telmo has told us. What should we deal with? Like, we want to switch the Wi-Fi to 3G, or we want to turn on, turn off the Wi-Fi. We used in some part like ADB commands, as you have used them, but for some mobile device, we have a phone utility class. So like, if you want to manipulate a Sony device or Huawei device, you call this methods and you use the implementation for every phone. And there is also another part implemented in the grid. So there are so many recordings and so many screenshots are collected during a test case. Like, think about the test case runs for almost 5 minutes, and you have so many screenshots. Where you are going to store them? We store them in the Amazon cloud. We push all the recording to the AVS service, so we don't have to deal with the local storage and other stuff. So we push all the recordings, all the screenshots to the AVS, just to get rid of the local storage thing. And let's see about the architecture of the project. As I said, one test case should work for both devices. So we have the same methods for every device. Like, this is for the Android part. So let's see. No, this is for iOS, and this is for Android. The names are the same. Send photo from camera with type, something like that. When you call this method, you say, I want to send the HD picture. And you say some type and do some stuff like click something, wait something, you choose something. There is some operation going on in the iOS side. But in the Android part is different because the UI change, the application change. So we implement the same approach for same functionality for both devices. And then in the before section, in the setup part, we define the devices. This is for just showing this is all hard-coded. It's not hard-coded in real life. They are always changing by our grid. And we set the synchronization, we start the synchronization server with the device name and what their role is. Like iPhone 6 Plus 9 is going to be the receiver. Android Huawei is going to be the receiver. We set all those information, all those status in the before session in the setup part. So we develop our test cases in a role-based thing. Like, if he is the sender, he's going to execute those 4 parts, and he is the receiver, he's going to execute those parts. Like, for the sender, he's going to clear the chat, he's going to send the photo from gallery, and that's it. But for the receiver, he's going to receive the message, download it, and open photo preview, or maybe reply back. So there is a role-based test case mechanism. And synchronization is always reset after every step. Like, you can see, we do some synchronization. It's set sender ready, set receiver ready. They are always synchronizing the device between the RESTful service. Before that, many of the test cases were failing because of timeouts or timeouts or waiter methods. So after this synchronization method, it starts to work very fine. And this is a demo that I want to show you. Let's see. This is an iOS, this is an Android site. The sender searches for some user. It's looking for me, Canberk. He selects Canberk right now. He's going to write some message to send. The other one is still waiting. After the sent message, the synchronization server tells the other phone to check if there is a new message. Right now, yes, it checked there. He replied back. And he makes a call by using the native component of the phones. Then we can turn off the Wi-Fi, turn on the Wi-Fi. This is just to show you that we can deal with the native components easily by using the ADB and the other toolset. And it's done. The one scenario runs on 2 devices with 2 different steps. So this is one of the things that we deal on this project, like maybe 3 devices or 4 devices can talk to each other, and they have to be synchronized in a frequent way to make the test case work smoothly. And thank you for your time. If you have any questions, I am ready to answer it.